Another ground reference procedure that involves flying in a figure 8 pattern around 2 points on the ground is the Eights-on-Pylons. During Eights-on-Pylons, you don't maintain a uniform radius around the pylons, nor do you try to maintain a constant altitude. Instead, your goal is to vary your altitude and airspeed to keep a reference point, usually located near the wingtip, on the pylons. This reference point varies depending on your sitting height and position and the wing design of your airplane. Regardless of its exact position, the key to selecting the reference point is that your line of sight through the point must parallel the airplane's lateral axis. When performing Eights-on-Pylons, you should maintain the reference point on the pylon so the airplane appears to pivot about it. The altitude that enables you to do this is called the pivotal altitude, and it is governed by your ground speed. As your ground speed increases, the pivotal altitude increases. Likewise, a decrease in ground speed causes your pivotal altitude to decrease. With all of this in mind, let's look at the planning and coordination needed to fly Eights-on-Pylons. After clearing for traffic, start by determining the wind direction, and then select 2 pylons that are in an open area free of hills and obstructions. They should be spread far enough apart to permit a few seconds of straight and level flight as you fly between them. The pylons should be aligned perpendicular to the wind and at approximately the same elevation to make altitude adjustments easier to accomplish. Plan to enter the maneuver near the pivotal altitude, which you can estimate by using this simple formula. First, approximate your true airspeed in miles per hour and square this value. Then, divide the product by 15. For example, if your true airspeed is 110 miles per hour, your approximate pivotal altitude is 807 feet AGL. You can also use the same formula with knots, but in this case, you will need to divide by 11.3. Since you seldom know your exact true airspeed, you'll need to find the desired altitude by experimenting as you fly the procedure. After you adjust power for the recommended entry speed, enter the maneuver by flying diagonally between the pylons. When you're approximately abeam the first pylon, roll into the turn. At this point, your ground speed is highest, which means you're at the highest pivotal altitude. As you continue the turn into the wind, your ground speed gradually decreases. If you fail to adjust for the reduced ground speed, the reference point moves behind the pylon. This means you're too high. To bring the reference point back to the pylon, lower the nose to descend to the pivotal altitude. As you proceed around the first pylon, your ground speed increases, so gradually raise the nose to keep the reference point aligned with the pylon. If you don't initiate the climb, the reference point moves ahead of the pylon. This means you're below the pivotal altitude. Remember, increased ground speed means an increase in the pivotal altitude. In addition, since a constant radius is not a requirement for this maneuver, you should not correct for any drifting. Therefore, use varying bank angle to keep the reference point on the pylon. The closer you are to the pylon, the steeper the bank. When the first turn is completed, roll out into straight and level flight for 3 to 5 seconds as you fly toward the second pylon. During this portion of the maneuver, you'll need to crab into the wind to correct for drift. Once you're abeam the next pylon, begin a turn in the opposite direction. As you continue the maneuver into the wind, ground speed decreases. Therefore, gently allow the airplane to descend to keep the wingtip reference aligned on the pylon. Correct for any deviations from your desired reference by gradually and smoothly adjusting your pitch attitude. During the final portion of the turn, your ground speed once again begins to increase. Thus, your pivotal altitude must subsequently increase to maintain the proper alignment. Continue the turn until you roll back to straight and level flight between the two pylons. The key to successfully flying Eights-on-Pylons is to hold the reference point on the pylon by changing your altitude, rather than using uncoordinated rudder pressure. Coordinated flight should be maintained throughout the entire Figure 8 maneuvers. Commercial flight maneuvers are designed to help you attain a high level of competency in controlling the airplane. As you increase your ability to precisely execute them, you'll also increase your understanding of the airplane's maximum performance capabilities as well as its limitations.